All right, here we go on Chapter 7, Section 3, problem number 11. You may remember this one from in class, and some of these were the ones we did in class. In a random sample of 12,447 hip replacement or revision surgery procedures nationwide, so our sample size here, N, is 12,447. 162 patients developed a surgical site infection. Hey, let's give a point estimate of the proportion of all patients undergoing a hip surgery procedure who develop a surgical site infection. So we have so for A, this is going to be the ratio of 162 that develop it over the 12,447 who were in their sample. And we look at that, so here our estimate of the proportion equals, let's see if I calculate that, that's 0.013. Okay. B, verify that the sample is sufficiently large to use it to construct a confidence interval for that proportion. So we're going to do P, which is 0. So we know this is that NP and NQ both have to be greater than or equal to 5. So since P is much smaller, Q1 minus P will be 0.987. So if NP is large enough, NQ is definitely going to be large enough. So in this case, we have NP hat because we don't know the actual proportion. And so this is 12,447 times 0.013, which gives us about 161. So yep, we're good. We're greater than 5. Okay. Construct a 95% confidence interval for the population of all patients undergoing hip surgery procedure who develop a surgical site infection. All right, so 95% confidence interval. So our alpha is going to be 0.05, and we probably have to look at the alpha over 2 here in a moment. So it's going to be 0.025. Boy, that really looks good, doesn't it? Anyway, so for our confidence interval, let's look at what's going on here. So we've got our sample portion. In this case, this is 0.013. So we're looking at this confidence interval. I probably should come down like this, right? So what's this confidence interval in here? So that we have 0.025 of the percentage on this side, or the amount of the proportion, well, I guess percentage of the probability, and 0.025 on this side. That adds up to our 95% for that confidence interval. So we're looking at what's in between there. So if we go and look in the book, or you might have this from memory even, so that our confidence interval is going to be the proportions of the sample plus or minus the standard normal z at alpha over 2 times the square root of p and q, 1 minus p hat, over n. So that'll give us our confidence interval. So the plus will give us this point on this side, minus will give us the point on this side. So the 2 points, that interval is what we're looking for. And I'm using my hands here, and you can't see them as I'm doing this. How about that? All right, so let's put our numbers in that we have. So we have, we're going to need this. Let's do this first here real quick. We have the z of alpha over 2. So z, and we had alpha over 2 is that, so 0.025. So we could get this a couple different ways. You could go into the standard normal, the cumulative standard normal table, and get the number out that way. Or you can do like I'm going to do and use the t distribution, the student t distribution table, at where the number of degrees of freedom approaches infinity at t at 0.025, which is the same as z at 0.025. And that one's spelled out, so it makes it easier to find it. So in the standard normal table, you'd have to go into the table to find where the 0.025 is. In the t distribution, we're given the t at 0.025 and looking at degrees of freedom infinity. And that number is 1.960. Okay, so our p hat, so we've got the 0.013 plus or minus 1.960, the square root of 0.025 0.013, and 1 minus 0.013, which is 0.087, divided by n, which was 12,447. Okay, so as we do that, this winds up coming to be 0.013 plus or minus 1.960 times 0.001. If you have enough decimal points in your calculator and the calculations, that might go out a little bit further there than just 0.001. And then we are going to multiply that times here, and we wind up with 0.013 plus or minus, what did I multiply those out? Oh, yeah, that's an easy one to multiply out, right? Because it's just a 0 there, right? 0.00196. 1, 2. Whoops, do I have an extra 1 in? Oh, I think I have an extra 0 in there, don't I? So this one, we're going to go over 2 decimal points. 1, 2, so 0.196. No, I had it right. 001. There's the extra 0 there. So we wind up then with our confidence interval being 0.011 and 0.015. So at 95% confidence, or the 95% confidence interval, is 0.011 to 0.015. And there we go.